Hi, I'm Hazel.
I'm Rachel.
I'm Tristan.
And I'm Jamming, and today we are going to talk about the set and relation. But before that, I would like to give a brief on what we will know by the end of this video. First, we will know what is a set and relation. Secondly, we will understand what is the three properties of relation. Thirdly, we will also understand what is an intersect, a union, and a complement. Last but not least, we will also know what is a third Mark's law. So what is a set? Set is a collection of objects that can be mathematically or not. You could see there are a set of cats and the set of books in this slide. Every item in the set is called an element of the set. When we are writing down a set, we use curly brackets to surround it. As a relation, we could see it as a way to establish a connection or relationship between the elements of two sets. Well, do you know there are also exist three types of relation? They are called transitive, symmetry, and effusive. Transitive happen if element A is related to element B and element B is related to element C. Then there must also be a relationship between element A and element C, following the same rule of relation. In other words, transitive means proving all the possibilities of elements in the set. For example, if you get ABC in the set, the answer for transitive will be AA, AB, AC, BB, BC, CC. As for symmetry, it happens if ARB exists, then BRA also exists. For all pairs of A, B that belong to set S, which means that if AB belong to R, then BA also belong to relation R. You could also understand it as a mirror. And for reflexive relations is mathematical or set theoretical relations in which every element is related to itself. In short words, reflexive look like a copy-paste function. Well, after understanding set and relation, let me pass the next topic to my trustee member Tristan.
Thank you. I will now take it from here. So how can we actually apply set and relation in real life? Let's look at the data. In a company, there are three parts that are responsible in manufacturing sweets. Part A is responsible in making apple flavor sweets, and Part B is responsible in making grape sweets, while Part C is responsible in making coffee flavor sweets. In order to increase the selling of sweets, three parts collaborate with each other to make a new packaged sweets that contain different group of these flavors. Part A collaborates with Part B to make a package that contains grape and apple flavor sweets. They plan to manufacture 20 boxes of these sweets. Part A and Part C also collaborates with each other by manufacturing 40 boxes of package that contains apple and coffee flavor. Part B and Part C also collaborate to manufacture 20 boxes of package that contains grape and coffee flavor sweets. These three parts also collaborate with each other in manufacturing 30 packets of sweets that contain apple, grape and coffee flavor. Now, let's draw the Venn diagram out by using this information. As you can see, a sweet represents 10 boxes of sweets. Here is the Venn diagram for what I had just said. So, do you have a clearer vision on what is set and relation?
Now, if you analyze the Venn diagram that was drawn by using the data that was given from our trustee member Tristan just now, you'll notice circles from set A, set B, and set C has actually overlapped on each other. This happens to be an intersect. The definition of intersect is that that contains all the elements that are common to both given sets. The symbol of intersection looks like a set face. Let's look at this example. A intersect B intersect C. You will get the result that is actually highlighted. As you will notice, the area was actually being overlapped by three of the sets, set A, set B, and set C in the same time. And what is a union? A union is elements that present in both given sets. Seems complicated? You could also think union as a plus function in the mathematical operation. The symbol of the union looks like a smiley face, which is actually the opposite of the symbol of the intersection. Let's look at this example. B union C. The answer will be the one highlighted. As you can see, set B and set C was actually added together. Did you get it? Now, before talking about the De Morgan's law, I would like to introduce to you complement. What is a complement? A complement is set that includes all the elements of the universal set that are not present in the given set. In simple words, you can memorize complement as a knot. Look at this example. A complement. The answer will be all the elements that are available except for elements in set A. In simple words, the one that are being highlighted.
And now, I am going to tell you what is De Morgan's law. Okay, so first, in set and relation, there also exists a law called the De Morgan's law. Did you know De Morgan's law are fundamental principles in set theory and Boolean algebra? It is attributed to the British mathematician Augustus De Morgan, and they describe the relationship between union, intersection, and complements in set theory. And these three stuff are just introduced to you in the previous slides by Hazel. Here is an example of the De Morgan's law using real life example or maybe pictures to help you understand better on what is De Morgan's law. It looks complicated, I know, but it may not be as complicated as you think. Let me prove it to you. Let me show you. In this photo here, the highlighted part is actually C intersect B. By throwing away these highlighted parts, we could get the answer for not C intersect not B. Let me prove it to you. Firstly, let's take out C. C is this highlighted part. And then, so the rest of the part which is not highlighted would be not C. And next, let's take out B. B is the highlighted part. And then the rest of the part which are not highlighted is not B. So when not C and not B is union, then we will get the answer which is not C intersect not B. So this picture proves the De Morgan's law correct. So this is all from us today. So thank you for your attention and hope you know more about set and relation. Thank you.